All right, we are live. This is going to be a really fun webinar. I'm really interested in this topic, and I always really think it's a good experience when we do deep dives on one particular project or company. So excited to combine those two things into a deep dive on this called it theory of mind, but there's a lot of other terms that hopefully I'll get educated on throughout the webinar. So minor logistics, and then we'll just jump right into it. We are recording. This will be available at the link afterwards, and then we'll put it up on YouTube at least by the end of the week. If you guys have questions, and I will certainly have questions, but if you guys have questions, try to drop them in the Q&A section on the right. So there's the chat section right now where everyone's saying hello, which is great. And then if you look below it, all the way to the right, there's a little box with a question mark. And so if you drop questions in there, you can also upload other questions that you want to hear answered, and we'll kind of just go through those in order of like most uploaded at the or honestly throughout the whole kind of like presentation. That's pretty much it. I'm going to hand it over to you guys now. And so, yeah, you guys maybe want to do quick intros and then just take it away.
For sure. Yeah.
Sure.
So my name's Vince. I'm a machine learning engineer. I come from background in higher education. I was working on a research and development team building ML apps at a major university in the US for a long time. And yeah, got with these guys to start Plastic Labs.
I'm Cortland. I'm a philosopher, educator. Spent most of my career in the classroom teaching language and philosophy.
Hey, I'm Vineeth. I've kind of been all over the tech stack from hardware to front end to security. Most recently, I was a PM at Microsoft. Joined the Plastic team once we started kind of scaling things out and started to think a lot more about the architecture, and haven't looked back.
Yeah. So I can give like the quick origin story, and then we can dive into the research. So we came together to start exploring what an AI tutor would look like. Having education backgrounds, we thought there was a lot to be desired in like a true like AI tutoring experience. And so Cortland and I started really jamming on like what would a pedagogically sound AI tutor look like. And the TLDR on that was, we came up with an architecture that was sort of like meta prompting to assess student needs. And we found that it was really good at doing that. But up until a point where it just didn't have enough personal context on users. And so we took a step back and we saw that was like a much broader opportunity to give large language model applications more context on their users. And that was kind of how the inception of Plastic Labs started. And so we spent 3 months in an accelerator program researching and building out an MVP of what this like framework might look like. And yeah, we can dive into it if that sounds good.
Yeah.
Cool.
Let's do it.
You guys want to just talk, or should I share the little diagrams we have? Or
Share some of those diagrams to get us started, and then we can bounce around. Yeah.
Cool. So yeah, here, join our Discord if this sounds interesting.
So yeah, we usually like to start this off. I don't know, being the resident philosopher here, I can't help myself, but we usually like to start this off framing this in terms of the principal agent problem, which, like, going back to Econ 101, basically describes all the ways in which coordination can go wrong when you try to delegate a task to an agent. And obviously, as we're thinking about how human AI relations are going to go and unfold, and the kind of tools we're going to build, that becomes really important to consider, right? Like, human relationships are really, really messy, and especially economic ones, and so full of information asymmetries and misaligned incentives. And so, if we want like our AI to be truly augmentative, then we ought to start thinking about some of these things on the front end here. So earlier this year, researchers noted that LLMs were just displaying emergent theory of mind abilities, and we found this really, really interesting in terms of solving some of those problems I just talked about. And the reason is that theory of mind is basically the capacity to predict what other people are thinking, and it's limited to just humans and a few other species. And so the fact that this is emerging in LLMs without being a task they're specifically trained for is like really compelling, and we can get into like why that might be happening and all that. But basically,
Do you know what was?
yeah.
Do you know what the evidence in the paper was that this theory of mind was emerging in LLMs? Like what exact kind of like study they ran or experiments?
Yeah, they ran they ran GPT, like the GPT series of models on these classic tests that developmental psychologists use on children, where they sort of lay out observations of like different actors in scenarios and like prompt the language model to make the correct selection as to like who is like missing information, or I think in this case it was like who has right information, or who is going to be confused.
Oh,
So it's like a multiple choice problem at its core.
oh,
Yeah, and they ask you know, when these kinds of tests are done on people, right? Like they're just asking, they're trying to design queries that that show that, you know, like whoever's being tested can think about other people's state of mind, like naturally. And so, you know, we probably need to, you know, we can talk about this later maybe, but we think a lot about how like what LLM specific like evaluations might be here, because obviously like this isn't going to be exactly like what's happening in humans. But regardless of like taxonomy, it's super useful, right? And so when we think about like, you know, when we think about trying to get LLMs or AI to act in like high fidelity with our interests, then we think this is like a really potent tool. So, like to improve, you know, the first thing we thought of was like, how do we improve this, basically, right? So how do we enhance this? And the first thing we did, since this is like, you know, a thing that biological brains do naturally, is to think about like how do humans gain the context that they need to improve their theory of mind predictions, and like can we mimic these kinds of processes in LLMs? And we found that we can. Basically, the brain learns by constantly making predictions about reality and comparing that with actual sense data coming in. And when there are errors in prediction, and when there's a difference between the prediction and reality, the brain learns something. And most of this stuff happens subconsciously in the dark, although you can use this as an active learning technique. And you know, it turns out that the LLMs are actually really suited to doing this too, right? We can do basically the same thing. So we designed like a prompting framework that you know, that forces the LLM to like actively metacognate on user behavior, compare that against their actual behavior, and then learn from the difference, right? Derive psychological facts from that delta. So yeah.
So this is
and this violation of expectation, is this like a pre-existing concept in psychology that you guys are borrowing from?
Yeah. So like violation of expectation is a concept from developmental psychology. And basically it is one of these mechanisms about prediction and comparison that humans use from the earliest stages. There's a bunch of studies on like infants and how they learn by having their expectation violated. And so, yeah, so we're really taking our cue from theories in psychology and cognitive science and seeing if we can, you know, how we can mimic those in our prompting architecture.
Yeah. And so this is kind of like the snippet of the diagram. So this was like our overall sort of like metacognitive architecture, and we try to break this down because this gets a little complex. The thing that you can see in the open source version of the tutor, which again, a bit of context for folks, we have open sourced an AI tutor. We have it implemented at chat.bloombot.ai right now, but the repo is open source. You can find that. It's called Tutor GPT, and it's under the Plastic Labs organization. But the way that works is whenever users say something, we generate a thought about the student's needs, and then we feed that into a response chain that uses that thought as like extra context to generate a response. And so really what we're doing on the back end of that is sort of enhancing the language model's ability to think about the user. And so what we do is, like echoing what Cortland was saying, we try to implement and mimic this violation of expectation method where we predict what the user is going to say, and we compare that to what they actually said. And the important thing here is like the metacognitive prompting part. We generate thoughts at every step. So it's not like one shot or like, single shot response generation. We're always having the language model reflect on what it's observing. And so we generate a thought about what the user is going to say. We revise that thought based off of facts that we can retrieve over a vector store. We compare what we thought they were going to say versus what they actually said, and derive facts based off that difference. And those get sent into a vector store that can then be retrieved over at later turns of the conversation. So, I think I'm over here. Yeah. Happy to dive more into like the like architecture and the LangChain side of these things. Is like, yeah, we built this entire thing in LangChain, and you can see that in the open source version as well.
Well, I think it's probably worth walking. So this is a really cool diagram, and I think this is the kind of like key bit. And I know like we discussed this a bunch in Slack, and I had a bunch of questions about this. So I think it is maybe worth just going over this in more detail, even just for my kind of like further education. So okay, so we have the where's the best place to start? If we start with the bot, so we start with the bot response.
Sure.
So from the bot response, in the background, what we're going to do is we're going to predict what the user is going to say.
Yes, and importantly, that's like a reflection. We're not like trying to predict verbatim. We find that like the language model is quite good at generating like accurate commentary, but really bad at generating like verbatim predictions of like what they think the user is going to say. And so like, go ahead.
No, I was going to go on to the next thing, but if you're going to clarify this part, yeah.
We're moving on. So the comment, like the reflection, the thought about what the user is going to say gets revised. So like we put in the chat message history for this one. And so the only context available to it at this point is just like everything that's been set up to that point in the conversation that will reasonably fit in the context window, of course. And then we take that and we ask the language model to revise that thought based off of any facts that it can retrieve from the vector store. So I think actually an important piece here is we are prompting it to do two things. We're prompting it to reflect, like generate a thought about the student's needs, and list out any additional data points that it would find useful to improve its prediction. So this is a two-part process. We described it in the paper. But what we do is we parse out those additional data points, and those serve as the query over the vector store. So whenever we ask it to revise that thought based off of facts that it's retrieved, it's retrieving based off of any additional data that it thinks it might that might be useful for improving that prediction about the user, which usually lends itself really well to querying over like psychological facts about like people's interests, their beliefs, their prior knowledge about certain things. And so usually the reflections, the thoughts, they get really dialed in after this step. And so then we take what they actually said and compare it to the
so just going back to the user thought, the thought revision, basically what you do is you take the original prediction, you take in the retrieved facts, and you're like, hey, update now what you think the user's going to say based on like these additional facts.
Exactly.
Cool.
Yep. And so usually that gets really dialed in at that point. And so this step generates a thought about how those two might differ, the revised thought and what they actually said. And so that commentary is then used to derive literally like a list of facts about a user that can be then stored, and we just check for redundancy at that point. But otherwise, they get stored. And so the same thing that I said happened.
How do you? So I think the checking for redundancy is actually quite interesting as well. So like, what is that? What does that involve?
Actually, it's pretty simple. You know, we derive like a list of facts, and then
Yep.
we like sort of iterate over the vector store on like a similarity basis to just make sure that like we haven't stored something super similar. We're not
So
storing
for each
redundant
fact-
facts.
So for each fact, you like look up things in vector store, and then what? You get back like 10 items and their corresponding similarities. Do you then base it off of the similarity? Do you pass it to the language model and ask it to make a decision?
Yeah, we ask the language model to make the decision.
Cool.
That's another. Yeah, that's a great point to clarify. We
And
find
then-
it like. Sorry.
No, go ahead.
I was just going to say, like, a broad theme in our work, and we've written about this on our blog, is that like we find that the more autonomy we give the language model to make decision, like the more intellectual respect we treat it with, the more we're rewarded. Like it's fascinating, you know, the limits of which you can offload cognitive tasks to these language models. Like, so sorry, yeah, just wanted to throw that in there.
And so okay, so you get back like the 10 most similar ones. You have your new fact. You pass it to the language model, and then what can the language model says like, yes, this is a good new fact to add. No, this is a good new fact. Like, do you update old facts at all? Like, if there's conflicting temporal information, like how would that work?
Yeah, that's a great question. Currently, we're just sort of like passing in like the facts we're considering storing, and then like the top K that we retrieve, and asking the language model to reason about like what the list should look like to not store redundant information. The temporal aspect of this is super interesting and like an area of future work for us. I think there's a lot of really neat things we could do there. We just haven't gotten to that yet in the MVP.
And when you say like reason about what the list should be, that's specifically like if you have 10 new incoming facts, you're like reasoning about whether that should actually just be 3 new ones or whether it should be all 10, like that. You're not changing any of the stuff that's already in there.
Exactly. That's right.
Cool.
Yeah. It's like given these are existing, these are new. Reason about which one should be stored based off like, you know, to not store like redundant information.
Cool.
Yeah. Well, so that, I mean, that
and
basically,
then
yeah, go ahead.
And then that goes, and then okay, so and then this is okay, so then you update the vector store, and then you've got this other bubble here, the theory of mind in violation of expectation thought.
Mm-hmm.
What is that representing in the bubble?
This sort of like square represents the open source tutor.
Okay.
What you can see out there in the repo right now. And so like really all this represents is like the thought step, and like in our version of Bloom, the hosted tutor that you can try out at chat.bloombot.ai, it's got this extra sort of like step that's retrieving. It's sort of similar to this up here where we have it generate a thought, but then we revise that thought. It's like our implementation of the tutor generates a thought just like the open source version, but revises that thought.
And the difference here would be the thought would be how the bot should respond, not how the human should respond at this for this particular thing.
Correct. Yep. Yeah.
Yeah. To add, I'll just say the reason that we have our tutor Metacognitive constantly at every turn of conversation is because we find that when it's constantly thinking about what the learner needs, that its responses are like way more in tune with their actual needs. So instead of originally we were trying to design change specific to particular like domains of learning and like figure out what the student objective was and funnel them there. And we found that if we just had the model constantly reasoning about what the student needs, that we didn't really need to define the objective at all, because because it's just always cohered to the needs of the moment. And so we found it was much more broadly capable without requiring like tons of high quality demonstrations or anything like that.
Yeah, I'll also add too that when we do that, and like one of the things I think we were talking a lot about was like this part where like, how do we determine what the bot responds with? We were like, oh, that's actually an important sort of thing. Like for us, is that we sort of just give it a lot of context at its disposal, like to reason about the best way to respond to the user. And what we found is that like GPT-4 and these chat models are trained super well to, like, for lack of a better term, like catch a vibe. If you give it like all of this context, like you're like, okay, here are the user's interests, here's the, here's what they know about this already, like things like that, and then you give it the chat history, it does a really good job of like determining on its own, like, okay, should I ask a follow-up question or should I just like respond with the answer? Do I need more information to better serve them, or should we dive deeper based on their interests? Like, where should we take this conversation? We find some really like interesting emergent behavior that way. And so yeah, it's like really, really cool to see how they handle this stuff.
And are the prompts for this open source or in the paper and everything?
They're like basically described in the paper. We're still, we're an early stage startup. We're trying to figure out our path forward here. We'd love to open source it. In fact, it's kind of what we're thinking is the future, like an open core sort of model. But not at the moment. We just have to get our ducks in a row a little bit here and figure out what we're doing. Yeah.
Completely reasonable. There's the reason I ask is because there's a good question in the chat as well, is like, what are the nature of the facts that the model ends up retrieving, and like, are there some examples? And I imagine like those really depend on the prompts you use, kind of. And so yeah, I'd be curious to hear how you guys thought about that prompting process and what you observed.
Yeah. We tend to focus a lot on user psychology, because we think that that's like the primary new potential paradigm here. So instead of traditionally we've thought about like getting to know users digitally as like, what's their activity, what are they engaged with, what's maybe plug in their email, their docs, their highlights, their notes, that kind of stuff, and then we'll know them. And that works, well to a degree. But like, if we're just doing that with LLMs, we think that we're missing a big opportunity, because they're able to reason over like really substantive psychological content, because the narrative space of the pre-training is like filled with that kind of stuff. Then we ought to try to leverage that. So when we're asking the model to store, so that's why we ask the model to store specifically psychological things. We think about like, what are the kinds of facts that humans gain from ordinary social cognition or interpersonal interaction, right? Like if I'm spending a lot of time with someone, I'm not like reading their emails or their docs or their digital artifacts, right? Like we're conversing. I'm getting to know like what we might say is the real them, right? I'm trying to figure out like their beliefs, their false beliefs, their personal history, their knowledge graph, their interests, hobbies, anything like that, right? And we tend to just like kind of absorb this passively and automatically, either, with a mix of interpersonal interaction and like social cognition, right? So I will ask like deliberate questions of someone, like to get discrete facts, if I'm trying to get to know someone. But my brain is also constantly running prediction on what they're going to say next, and how they might behave, and then comparing that to what I actually observe and deriving facts. And so that's what we're trying to mimic here. And so when it retrieves, when it stores things, it's just storing stuff that comes from that prediction error, right? From the difference between what it thought you would say and what you actually said. Because if it predicted something correctly, then it doesn't really need to know that about you, right? It already is able to intuit it. And yeah, what that ends up being is that kind of suite of psychological stuff. And so then when it retrieves that information, that's what's happening. When we talk about it, like in the context of the tutor, for example, like what we find is that the model is much better able to keep track of like what a student knows. It's able to synthesize concepts across interactions over time. It's able to like contextualize concepts in terms of something it knows the user is interested in, right? Like it knows you're interested in soccer, right? So if it's trying to explain velocity to you, right, it'll frame it in terms of soccer, and it'll reference a previous conversation. And we find that's a really like basic example, but we find it does that like across really impressive domains, right? There's a bunch of like Swedish Wittgenstein PhD students using Bloom, and it's able to like synthesize. It's able to synthesize like multiple philosophers and multiple discrete concepts within their philosophy between conversations and make connections like that weren't there before. And so, I mean, that's like a knowledge graph example, but it's, you know, it ends up being like really powerful.
The other thing I'll add there too is if you want like the closest thing to like seeing what the examples might be, you can go to chat.bloombot.ai and try it out. And we have a toggle up in the top right that allows you to see like the thoughts of the bot. And that's where it lists out that additional data that it thinks would be useful. And so usually like it's like things like your interests or your prior knowledge. And that's what that's the type of data we're going for.
And I just dropped that link in the chat because I'm definitely going to play around with that after. All right, moving on to some of the questions that we've got in the question box. The first one I think is really good. What are the data formats you recommend for storing memory? What are considerations for building? And so just to kind of like look at that diagram that you had, it seems like you're using a vector store and you're storing like facts, but not the raw conversation things. You're storing like the LLM reflected things. Is my understanding correct? And then is there any other data formats that you tried? I think a lot of people are interested in graphs, more structured representations. Yeah, I would be really curious to hear your thoughts there. By the way, this is such a good slide. So
yeah, close it too soon.
We love Excaladra.
Yeah, normalized Excaladra. We're storing natural language at this point. I think there's a lot of opportunity to do really interesting things, storing like embeddings, learning tokens in this regard. But yeah, currently it's quite simple. Like we derive like a list of facts and then we embed those and store those vectors. And so yeah, anything to add?
Yeah, it's essentially like a retrieval augmented generation there at the VOE step and the thought revision step. So the vector store is just to make that process a lot faster, but we haven't really seen any issues with like just storing natural language or JSON, especially for like chat message history. I think there's some questions related to like context windows, and there's like a lot of creative things that we've messed around there with kind of how to optimize the context window. Sometimes we just take the last 10 messages, but I think we've also looked into at one point we were using like conversation summary buffer window, which like kept summarizing the memory as the chat was going. And then we've like played around with some ideas of like only putting the most recent messages in, but making the past chat history queryable to the agent if it
like as a tool basically, where it could choose if it wanted to.
Yeah, because what we do is a lot of this like telling the agent to think about what it needs, and if you treat the memory as a tool, that it can decide that it needs more context and not necessarily just on the user, but just on the conversation. There's some opportunities there of like letting it figure out what it needs essentially.
Yeah, and that was a great segue to the next question, which I just put up with Shar. Like, what are the challenges of long-term memory for agents, and what solutions have been working best? What does the next step look like for context window friendly and reliable long-term memory? So you talked a bit about, so it sounded like summarizing the conversation, only including kind of like most recent messages, letting the agent like look up if it needed to. These were all things you experimented with. Any other additional stuff to add? And what is live right now in app.bloombot.ai? What are I think there's a great, like, you can talk about everything all you want, but I think it's really interesting to see what you guys actually chose to do. And so I'd also be curious to with all these different options, which one emerged victorious for you?
I mean, so the live one is just it's saying like the 10 most recent messages for the chat context, and then for the revision steps and all the extra like thought stuff there, it's kind of searching across the entire vector store. I think right now we're kind of like playing around with a couple different ways to do the window, and I think it's just like a matter of like finishing up these experiments and deciding if we want to push it to prod or not. If you look at a repo, we have like a ton of different branches. I don't know if anyone's really monitoring that closely, but you can see like all the different iterations of the different modules. And then I think, one of the main challenges that I've noticed is just like the kind of like decay in models over time, when like I've seen like a lot of instances of agents just over time like starting to spit out like gibberish. And that could be because of like Unicode errors or just like token issues.
Hyperparameter tuning,
I-
like playing with the
Yeah.
temperature and like top K and stuff like that, or top P, sorry. That's been a fun one to hone in. We actually I think, I can't remember, is our temperature still a little higher than normal on Tutor GPT?
Temperature is still like higher, but we tuned the top P to prevent the gibberish from coming out.
Yeah, that was actually that was a fun sort of, I guess, like practical experiment. Like we found that like if we can increase the temperature slightly and then constrain top P a little bit, we increase the likelihood for our tutor to behave and start, like not just sounding like a large language model. You know what I mean? Like it wasn't so rote. It was much more like engaged and had a bit more personality, which I think is something people are critical with the OpenAI models about. They become a little lobotomized and just like boring. But hey, you can play with it. You can play with the parameters, and I think you can find some really interesting results that way.
I think some of the work in attention sinks also, I think that was a paper I read recently, is kind of interesting, and like maybe a model for looking at context windows too, of storing some of the original conversations or original messages from the beginning and then only changing out a certain amount at the later part of the window. That paper showed a lot of results and kind of just improving the coherency. Sorry to cut you off.
One thing that I'll also add, I think yes, the data format that you guys are using is a vector store, which maybe isn't as as novel as like a graph or something. But I want to I think one, this is extremely similar to what the generative agents paper did. And two, it's more than just a vector store, because you guys aren't just storing the raw events, you're storing like the reflections of the LLMs. And I think that's like the the new thing here isn't data structures, it's LLMs. And then there's something about what the best data structure for an LLM is, but that's a separate thing. Like the new thing here is the LLM, and I think taking advantage of that to store these reflections is really, really powerful, even if the data structure itself seems incredibly similar to some of the standard you get started with vector stores off of RAG. It's actually you've got this layer of the LLM reflection, and I think that's the powerful bit here. And so
absolutely, it's what's in the data, not how it's stored.
Yeah, couldn't agree more.
This is an interesting question. So it's interesting to see new LLM frameworks emerge to mimic human brains. But how soon do you think we'll start seeing more ways to improve LLM capabilities that aren't modeled after human brains? And maybe tying this into some of the stuff, a lot of the research here is based off of developmental psychology for kind of humans. Do you think that maybe falls short in some areas, and there's some kind of we could get to better responses if it is very open-ended, but yeah, I don't know if you have any kind of thoughts on are you guys going to continue pursuing kind of existing developmental psychology ideas? Are you very open-ended? But I thought it was
we think a ton about where we can leverage the edge of lots of different seemingly disparate domains. I mean, cognitive sciences is kind of an obvious connected one, but But yeah, we plan to, we think a whole lot about theories about how the brain works in cognitive science and its its connected fields and how we might leverage those things. But yeah, totally agree that there's probably like an entire space of overhung capabilities that we're not really aware of, and I'm not sure that we're going to like find out what those like AI or LLM native methods are unless we just like keep trying to we keep sort of like working down the list of what we know about like how reasoning can be done based on like what we see in biological brains. But yeah, like have no doubt that there are like truly novel, I guess, reasoning capabilities or other intellectual processes that are possible with LLMs, because they really are like a different kind of intelligence, right? They're excellent at simulating. I mean, they're excellent at simulating in general, and so the fact that they can simulate, human processes is really impressive. But like, yeah, they could presumably simulate, anything else we can dream of.
Yeah. Next question, I think, is top of people's minds on a lot of things, but how did you measure the performance of these heuristics, and what did you learn about the relevance of those benchmarks? So yeah, evaluation, like how do you evaluate something like this?
Yeah, so what we did was the existing theory of mind sort of benchmarks weren't really suited for our use case, because ours is like conversational, like social cognition type stuff. And so like we want to create much more sort of like robust academic benchmarks for these types of things, but the best we could do was sort of run an A/B test on the back end of Bloom. And so we had a period of time where if you signed into the interface on chat.bloombot.ai, there was like 50% chance you got served the version of Bloom that's like strictly what we have in the open source repo, or you got served the version where we were running this metacognitive like prompting framework on the back end. And yeah, what we did was we evaluated the performance of whether or not doing this entire like like huge chain of prompts was worth it by seeing if it was improving the language model's ability to predict what the user was going to say. And we use the language model itself to evaluate its performance. So like we would like, that's the eval repo is open source. That's on Plastic Labs GitHub repo. So what we said was like, okay, here's what we thought they were going to say. Here's what they actually said on a scale of 1 to 5. Rate your accuracy. And so what we found was that with the violation of expectation framework running in the background, it made the language model more right in its predictions and less wrong in its predictions over time. And yeah, ran a chi-square test on that. And so you can read, you can see the details of that in the paper. We're actually working on updating the results right now. So.
All right. Next one I also think is interesting. How do you did you guys try to assess how much coverage of psychological facts you already have? So like based on interactions and the number of vectors that you have, how well do you actually know the user?
That's a great question. Currently, it is just like based on whether or not we're storing new facts. We actually haven't really dove into like in aggregate, like how many times it's sort of deducing that there's no new facts to store. But that's a super, super interesting thing. I think that's like kind of on at least top of mind for me as we head into the future, like on the roadmap of things to do. But yeah, I think the idea is that these improve with, in aggregate. Cortland speaks a little bit about this.
Yeah. I mean, we certainly found that that like it makes it's making, the model's making better predictions about individuals, right? It's less wrong, it's more right. It's doing impressive synthesis. But yeah, we haven't like jumped into all of the types of things it's learning and how we might cluster those and think about those, and then like where the gaps are. But yeah, I think
it's a great question.
You asked me something, I forgot. Yeah.
No, that was it. Javier, if that sounds interesting, hit us up. Love to chat about it.
This is a fun one. Was the name Bloom influenced by Bloom's taxonomy?
Yeah.
Yeah. Originally, like Bloom's 2 sigma problem, right? That it's possible for one-to-one instruction to produce results, 2 standard deviations better than one-to-many classroom paradigms. So yeah, we thought that like the advent of LLMs represents like a big, a huge opportunity to normalize one-to-one instruction for like orders of magnitude lower costs. Actually, we talk a whole lot about like how a lot of these AI tutors and chatbots right now are essentially still like one-to-many tools, because everyone's kind of getting the same thing, the same out of the box thing, and like, there's watermarks on lots of these tools asking students not to share personal information, but so like to really realize like what one-to-one instruction means, it has to not just be like, an on-demand learning companion that you can access anytime, but it has to be personalized, right? It has to learn about you, and it has to be able to meet you where you are, and it has to think about novel ways to produce learning outcomes for you, just like an expert tutor would. And so I think the way to do this is for it to get really good at theory of mind prediction, because that's what teachers spend. That's what makes a great teacher great, right? If they're in a setting where they're able to form more substantive relationships with their students, then that's a big part of what they're doing, right? They're constantly thinking, they're constantly building psychological models of each student in their charge, and thinking about how they can create a learning outcome for them, and then how those models intersect with one another, right? And how they could create a learning outcome for leverage the whole class to create a learning outcome. And so we think that frameworks like this are the beginning of getting to a place where we actually can realize and normalize and solve Bloom's 2 sigma problem.
Another one that I like is, and this goes back to the memory bit, and I know we chatted a lot about this, and I think we said how vector stores were, it's not just vector stores, it's kind of like adding things into vector stores. But did you see any kind of like edge cases or limitations of storing things in a vector store and retrieving them kind of like based on semantic similarity? Was there any examples where more structure might come into play, or was it pretty fine for everything that you guys saw?
I don't think we particularly ran into any edge cases, but I think, this raises a question of like, there's probably, there is like open research to be done on like ways to push this even further and like push what is semantically good or not. I mean, we've already kind of seen that like letting the model decide has really given us really strong results on like deciding what's important or not. And like, maybe there's some paradigms here to expand that for RAG, and not just relying on like the text embedding model, but also some more like cognitive information in that.
We're still kind of exploring all the ways in which this data is being used and can be used by the language model. Like we're very intentionally giving the language model a lot of autonomy to decide how to respond. And like, given this extra information, we've seen some really interesting emergent behavior. But like, like Cortland was talking about, like the overhung capabilities, the space of overhung capabilities that we think is still quite broad. And so like, all we're doing is trying to like increase the context that the model has in order to explore that space more. So yeah, it's subjective by nature. So like I don't know that we hit too many like clear
Yeah.
limits, but like yeah, it's a super interesting problem.
That makes sense. There's another good question around basically short-term versus long-term memory. So like, what might be relevant for them in a conversation is maybe, not a defining characteristic of them, and so there's that difference there. How do you kind of like think about that? Like, is the vector store aimed entirely at only like these more like long-term memory type things, and then you just expect short-term things to be within the conversation itself? Yeah.
I think the vector store is right now primarily focused on storing the psychological data. And because we built the tutor in such a way that it's sort of like at every conversation turn, updating its thoughts on how to best serve the student, we are intentionally sort of like trying to solve for short and long-term memory there. Like at any given point in the conversation, it should be able to change the way it's thinking about a student, which would inform the things that it would think would improve its prediction. So like that's like how the query gets formed over the vector store. And so yeah, like it's we try to subvert that problem as best we can. I think it would be my answer. You guys have anything to add?
Yeah, I mean, the vector store is more just like facts about the person and like characteristics about them versus the chat history is like kind of like what's going on in the moment. So I think just that split there is already kind of like a long term versus short term thing. But to Vince's point, like letting the model be as fluid as possible so that it can really adapt, um, just kind of makes it so it figures it out.
Yeah, I think we, like a big, relatively like a big direction of future inquiry for us too is like what kind of async reasoning we can be doing over the vector store in the psychological model,
Yeah.
and what kind of facts can, during a conversation or an interaction in some other paradigm, like what kind of facts can we keep on deck, or what kinds of like reasoning products can we keep on deck that might be leveraged in, in the conversation or the image generation or whatever it is that you're trying to do.
Sense. Cool. I think I think that's probably brings us to the end of the webinar. There's a lot of questions in the chat around how people can keep on talking about this, because I think there are a lot of different things that we could go down, and I see some existing questions, and so I know you guys, yeah, you've got the Discord, so that's probably the best place to take some of these questions. Anything you guys want to leave us with? Final words of wisdom, thoughts?
No, we're super excited with what you guys are doing over at LangChain and LangServe stuff. We see this like the evolution of the space being really conducive to what we're trying to do is give agents more sort of like tools to think about and augment their behavior. So, Cortland, you want to add anything?
No, I mean, I would just say like, our ultimate goal is to be able to trust agents to be like as autonomous and as capable as possible. And so bringing them into like extremely close coherence with your psychology, we think is like a major component there. And so we want to build tools that enable that. And yeah, so we're also talking about how we can like generalize this and make it into a horizontal service. And so we'd love to talk to anybody that's interested in working on these problems or using some of these features or plugging this stuff in.
Yeah, and just last thing is like we're really big on open source, so like we really welcome anyone to come in and if you feel like we've made bad decisions about how the things are built, like let's raise a PR. We can talk about it.
Yeah, and you guys have some great repos as well, both the eval and then the tutor GPT repo that I would encourage everyone to check out. All right, well, I really appreciate you guys coming on. I'm really interested in this topic, and this is one of the best papers I think I've seen on this topic since like the generative agents paper. Like in my mind, these are like the two kind of like most interesting things in that space. So yeah, really appreciate it, and looking forward to hearing more about what you guys get up to. And thank you everyone for tuning in. This was definitely one of the more engaged webinars that we've had, just in terms of messages. So I think you can, like, everyone's really interested in this topic, and so I'm sure there's some good conversation to be had offline as well. All right. Goodbye, everyone.
Yeah. Thanks, Harrison.
Thanks for coming, everyone.